Good evening, my 12th standard warriors. Welcome aboard to the Pathfinder series revision class. And this is like a one-shot crash course for all those students who want to cover up different chapters of 12th standard syllabus, especially in term 1. Let me tell you, on our channel, just few days back, I completed our syllabus for the term 1, which you can watch it over here. You just go to the playlist, you go down and go to JEE Physics, and once you are here, you will find different kinds of playlists in this JEE Physics section. You will see this Nurture series is for 11th standard, Pathfinder is for all the 12th standard students. It's a long-term series. If you go here, you will find all the lectures right from beginning. But if you want chapter wise, you go little bit below and you will see the chapters are over here. Electrostatics, 6 classes you will see. Gauss's law, 6 classes. Current electricity, 8 classes. Capacitors, 5 classes. Magnetic sources and effects, 5 classes. Bar magnetism, Earth's magnetism, you will see over here. EMI, alternating current. All the term 1 syllabus was completed over here. So these are in-depth classes. But here, right now, today, we are going to do a rapid revision so that you guys are up to speed. And if you have some backlogs, or if you think that you have very slight idea on capacitors, today's class will probably touch up on all the different aspects of capacitors. So welcome aboard. This is Shreyas Sir, your physics master teacher, leading the physics department at Vedantu. Hello Anil Kumar, how are you? Hi Ishwara, Alisha, welcome Albert. Hello Vimala, Shruti, Balaji, Aishwarya, good evening. Hi Russell. Okay, so Alisha, you have backlog, so don't worry, bacha. Guys, just do one thing. Just promise me one thing. This is what you're going to do. After watching today's class, I just showed you where you will find my remaining classes in detail. So please watch that. So there might be a possibility that in capacitors, maybe you know everything, but maybe you don't know RC, charging and discharging. So for that, if you want in detail class, there is a lecture available. But today's class is mainly, we are going to touch upon all the topics, in one shot. So welcome aboard. Don't worry, today's class will definitely boost up some confidence in you guys, and you will definitely clear some amount of backlogs that is there in capacitors. You'll also find the previous backlog sessions like electrostatics, Gauss's law, in the playlist again. So let's get going. Hi Shan, Anil is good. I'm also good. Hi Larib. Hi Chennai Vidyal. Welcome. Good evening. Hi Amazing eFootball. Welcome Akshaya. Good evening my warriors. Good evening. So what is the next chapter of 12th? Ishwara, we will start the next chapter of 12th after some time, because right now term 1 syllabus is on priority. I'll be doing some one-shot videos of the remaining chapters if you want, but in detail we'll cover it after your term 1 examination, because JEE mains will be very late. Don't worry, it's going to get shifted. It's not going to be in January or February for sure. Okay, so guys, if you really want to study under me and teachers like me, and you want to get these amazing ranks like our Vedantu students have been getting, our topmost rank this year in JEE mains was All India rank 35. There were so many students, like around, you can see 444 students in the top 5,000 ranks in JEE mains. Yes, that's right. 444 students in top 5,000. You can see so many students scored above 99.9 percentile. That number is 78 students. That's crazy. And we give you all the material, assignments, test series, whatever is needed for your preparation. If you are not happy with your coaching, do consider joining the batch which is just going to start on Monday. And there are 3 versions which you can check out. In the description box below, there is a link for joining the pro subscription. Go ahead, join it. You have option to join via EMI. You can try it out for 1 month. The course price is as low as 3,060 rupees per month. That's very affordable. I'm pretty sure you will consider this. So let's start with capacitors, and starting with charges on a capacitor and what is capacitance and all of that. Okay, so Anil, I think it will be conducted after Feb only, bacha. So Chennai Villa, my expectation is it will be in March. Yep, that's what my expectation is. Probably you'll have 1 attempt before April, and maybe the remaining 2-3 attempts will happen after April when your term 2 examinations will be conducted. So don't worry, you have a lot of time. Hello Shreya, welcome aboard. Okay, let's get going. And sir, what will be the duration of the session? Shayan Ghosh, approximately 1.5 hours to 2 hours. Okay, so around that. Okay, yes, too much time is there. That's why, Anil, I want to cover everything properly. I know some channels and some teachers are trying to see, it's not that they are having ill intentions, but everybody is trying to hurry up the syllabus and trying to complete it very fast. But I do not want to hurry it up, because what if you do not understand and what if you lose confidence? We have time, we will complete it much before February. That assurance I can give you. In fact, we'll complete it in January itself. Only 2-3 chapters are remaining, not much. Waves, modern physics, and probably, you know, little bit of maybe thermo and all of that. That's it. It will hardly take any time. Don't worry, it will get over like this. All right. Charge on a capacitor. See, what is a capacitor? Capacitor is nothing but a device which stores charge and energy. So that charge which is stored on the device, all right, it depends on the shape, size, and how much voltage you apply. See, when you have two conductors, if you take out some charge and put it on the other conductor with the help of a battery. So you take a battery, battery of voltage V, you take out the charge and put it over here. So there will be some field and there will be some energy stored in that device. That device which stores charge and which creates field between the plates and it stores energy, that is nothing but a capacitor. Now, if you put more charge, the voltage will increase. Why? Because higher the charge, higher is the field between them. So more charge, more voltage. And this proportionality between the charge and the voltage is given like this. So the charge stored will be C into V. Q is nothing but the charge on the capacitor. V is the potential difference between the plates. This C is called as the capacitance, and the unit of capacitance is farad. So 1 farad will be when you store 1 coulomb of charge, bring voltage down, per unit volt. So 1 farad is 1 coulomb by 1 volt. Keep this in mind. Good evening, Satvik. Yep. So 87 percentile, let's say, means the chances are very less, bacha. I doubt it. You can think of taking a drop, because you know you won't lose too much of time, and plus the next JEE mains will happen in another 5-6 months. So if you want, you can give it a try once more. There is a dropper batch starting on Monday, bacha. Glad to know that, Shreyas Sparks, and I hope you are enjoying this, Shreyas Sparks. Okay, thank you, Satvik, for all the love from AP, bacha, and all the different parts of the country. Now, having said this, okay, so remember, there is always some field between the plates. So if there is you know, charges on the plates, there is always some electric field. So this is the electric field between the plates. And since you have two opposite charges, obviously there will be some force of attraction as well. Okay, so there will be obviously the positive and the negative, they will attract each other. So there will be nothing but some force of attraction between them. The values of these forces and field you should remember. Okay, if you want in-depth derivation, I have done it in my long-term batches, you can watch it. But for now, just remember the formulas. The force of attraction between the two plates or the two conducting surfaces of a capacitor, the formula for that is Q square by 2A epsilon naught. What is A? A is the area. What is epsilon naught? Permittivity of free space. What is Q? Charge magnitude on any one of the surfaces. Keep this in mind. Similarly, the field between the plates is very similar to this formula, except for one Q will not be there and the 2 will also not be there. That's how you are going to remember it. Q2 not there in E. Q2E not there. That's how you can remember it. So for the field formula, remember that Q will not be there, 2 will not be there, only Q by A epsilon naught. So this is the field between the plates of a capacitor. I hope this is clear. No, Anil, I am taking the class today at 5:30 so that I can take the classes till 7:30 or maybe, I don't know, around that time. So that's only one class today. So instead of 7:30, I am taking the class today at 5:30. Hello, Hariharan, welcome aboard. Hi, Surya. गुड इवनिंग सर। जो फील्ड है वो इलेक्ट्रिक फील्ड है ना, बिल्कुल लहराबाद ना, वो डेफिनेटली इट इज एन इलेक्ट्रिक फील्ड बिकॉज इट्स इलेक्ट्रिक चार्जेस. Definitely it is electric field. You can see that epsilon naught and all. Epsilon naught is used in electricity. When you use mu naught, it is in magnetism. Okay, so if you want this notes, don't worry, you are going to get all the notes like this in a beautiful PDF form. कहाँ पर मिलेगा PDF? Where are you going to get the PDF? You are going to get it in the description box. There is a link for joining the Telegram channel. So join the Telegram channel. Okay, so just make sure you join the Telegram channel, and you will get the PDF very soon, by tonight or maximum tomorrow morning. Okay, so let's get going. Hi Logesh, welcome aboard. So let's start solving some questions coming up on your screen, and here it is. Come on my warriors, let's see if we can do this. The capacitance of a parallel plate capacitor is 2 microfarad and the charge on the positive plate is 2 microcoulomb. If the charges on its plates are doubled, then the capacitance of the capacitor becomes how many times? Vanakkam Abhinesh K, welcome aboard. So what do you think it is? What will happen to the capacitance when you increase the charge and make it double? And okay, so some of you are saying C. Thank you Logesh for all the love from Tamil Nadu. Welcome, welcome. A lot of people are from south, I know that. Welcome, Vanakkam, all my lovely warriors. Yep, come on, think about it. Hariharan saying C. What do you guys say? Will it become 4 microfarad? Will it become 1 microfarad? Will it become 2 microfarad? Or cannot be ascertained in the absence of information of the potential? Well, most of you are saying C. Q is equal to CV. Here it is mentioned that the charge on the plates is doubled. So if you double the charge, lot of you might be thinking, sir, capacitance will also double. That's wrong. Capacitance will stay the same. In fact, the potential will double. You will be like, sir, why? Q is increasing. How do you decide whether this will increase or this will increase? Remember, capacitance only depends on, this capacitance only depends on the shape, the size, okay, the type, and the dielectric material inside it. Okay, the dielectric material, we'll be talking about dielectric in a bit, but it depends on the masala inside, the type, the size, the shape. So it depends on what kind of capacitor it is. Once you have a particular capacitor, the capacitance won't change unless you change the width, change the area, or put some masala inside it. Okay, so hence the answer is remains 2 microfarad. Very good. Let's get moving to the next question coming up on your screen. So basically what do we have? A capacitor is connected to a cell of EMF E. It has some internal resistance. When the capacitor is fully charged, the potential difference across the cell is less than E, across the cell is E, across the capacitor is E, across the capacitor is less than E. It's a multiple correct, more than one options may be correct. So this is your battery. It has some internal resistance and it is connected to the capacitor. Think about it. What do you think will happen eventually? Okay, so this is some internal resistance. Come on my warriors, come on. Yes Karthik, even 11th standard will also have term 1 examination, but it is not a board examination. It is an internal assessment or internal examination from your school side, Karthik. Okay, hello Crack with Gogulnath. Okay, welcome aboard. Got it, Anil Kumar. Okay, Hariharan saying B and D. What about others? So when it is fully charged, what do you think will happen? Once it is fully charged, what will be the voltages across the battery and the capacitance? Okay, Hariharan is always quick in answering. Come on my warriors, push yourself, think carefully. What is the meaning of fully charged? The meaning of fully charged is that the charge on it is steady. The charge is reached the final value, it is no longer changing. And if the charge on it is constant, it is steady, that means the current is basically zero. No more current will flow in the circuit because it has finally got its final steady charge. When current flows, it will circulate the charge. Now no more charge is in circulation. So the current is zero. If the current is zero, think about it. the voltage difference over here, okay, which is I into R, the voltage difference will be also 0 because the current is 0. So there is no voltage drop across the resistor. I hope you guys got it, because IR is 0. But if you think about the battery, this terminal is 0, this is plus E. So this terminals have a voltage of E volts. How many volts? E volts will be there across them. So the battery will have a voltage difference of E. Okay. As such, if you think about it carefully, this entire thing is the battery. So even if you take the total potential difference, remember this does not have any voltage difference across the cell, it is still E volts only. Now, if this has E volts, obviously you can see both of them are in parallel. These 2 points and these 2 points are in parallel. So what will be the voltage finally? It will be E only. So eventually the capacitor will have E volts. So whatever is the EMF will be transferred over here. Completely it will get replicated because there is no voltage drop across the internal resistance. If somebody asks you, what is the charge on the capacitor? Q is CV. C into voltage. What is the voltage? E. So that's the answer. I hope this makes sense. Everybody got it? So B and C both are correct. B and C, not D. C is also correct. Capacitor is also going to be E. So both options are correct. Come on, my warriors. See if you guys got it. Put up a yo, put up a thumbs up. And if you have forgotten to smash the like button down there, please do that right now. It means a lot. It shows your love and support towards me and towards this channel. Thank you guys very much. Okay, chalo. Let's move on to the next question. This is also very interesting. Coming up on your screen. Very good. Very nice question coming up on your screen. There is a circuit and it has a section AB which is shown in the figure, and the potential difference between A and B, between these 2 points, is V volts. Then the potential difference across C1. How much is the voltage across C1? Okay, let's try and do this question. First of all, these 2 capacitors are in series. So whenever capacitors are in series, remember one thing. See, in current electricity you would have studied when 2 resistors are in series, what is same? Current is same. In the resistors, current is same through resistor. In capacitors, charge is same. That's the only difference. So both of them will have the same charge Q. Remember, Q is CV. Okay, keep this in mind. So Q will be C1, V1, and here also it will be C2, V2. So the voltages obviously will be different across this guy. It will be V1, across this guy, it will be V2. Okay. Now, here is what you will do. Use your Kirchhoff's voltage formula, Kirchhoff's voltage loop formula. Start from A and go towards point B. Start from A and see what and all do you encounter. Where does potential drop? Where does it increase? Where does it increase, decrease, constant? And finally you will reach point B. So go from point A to point B and see what and all drops or rises do you encounter on the way. You start from A, the potential is A. The first thing you encounter is capacitor. You are going from positive to negative, high to low. That means there is a drop of how much? V1. I hope this makes sense. You're dropping the voltage by V1 volts. Next, you are getting a battery. You are going from negative to positive. That means you are increasing the voltage. You are raising the voltage. You are going to higher voltage. So it will be plus E. Next, you encounter this capacitor. You are going from positive to negative. That means there is a drop. That means there will be minus V2. And finally we reach B. So whatever increase, decrease, etc. happens, the total sum of the voltages will give me the potential at point B. Everybody clear about this? Suresh Kumar Noonpari, join in bacha. Thank you Jitesh Yadav so much. Surya, join in even if you have missed something. Glad to know Alisha you understood. Let's go to the next one now. What we'll do, take VB on this side. Why? Because it is given potential difference between A and B is V volts. So VA minus VB, okay, minus or plus E will be equal to V1 plus V2. V1 and V2 I take it here. What is VA minus VB? It is V. Okay, plus E is equal to, what is V1? V1 is Q by C1. So it is Q by C1. And what is V2? V2 is Q by C2. Achha, I think I can take LCM. So it will become Q C1 plus C2 divided by C1 C2. That's what I'll get. Therefore, Q will be equal to V plus E, okay, into C1 C2 goes on the top. C1 plus C2 comes below. Now, the question was not to find the charge Q, but it was to find the potential difference across C1. So what is the potential difference across C1? It is V1. So what is V1 by this formula? It is Q by C1. So take this and divide it by C1. If you divide it by C1, this C1 will go. So you will get V plus E. If you want to write it down properly, C1 C2 divided by C1 plus C2. The whole thing divided by C1. So you will clearly see that this C1 and this C1 goes. You will get this formula, which is exactly option C, I believe. Hi Likit, hi Preeti, welcome aboard. So guys, see if you guys are see my warriors, if you are understanding this question, what has happened. All right, my warriors, see if you understood it. The first part was to realize that each capacitor is in series, so charge is same. Use the formula Q is CV. Next step, start from point A and see where is the increase, decrease, etc. You reach point B via Kirchhoff's law. You substitute the values. You found the charge. Once you find the charge, my warriors, that's it. You will get the voltage which is charged by C1. That's it, my warriors. Okay, excellent. So that's option C. So you can try it out on your own later on again. Okay, chalo. Yes, that's it, option C. Moving on to the next one. This is very tricky. Many of you are going to make a mistake. It's very, very simple. If you get the concept, that's it. This is oral question. You don't even have to write anything. Two parallel metal plates carry charge Q and minus Q, respectively. A test charge is placed between them. It experiences some force. Now the separation between the plates is doubled. Interesting. So what is the new force on the test charge? For those of you who are finding it difficult to visualize, these are the two plates. Think of it like capacitors. This is positive and this is negatively charged, and you have placed a test charge over here. Now what you do, you have increased the separation between the plates, you have doubled it. Okay, so now the charges are over here. This is the negative charge, and now the question is, on this charge, what will be the new force? Let's see how many of you can get this. Ramu, it's okay, even if you are late bacha, you can still join in. And I'll tell you, even in a live class, you can go back a little bit. You can catch up at 2x speed and reach the live part. That's a possibility. So you can do that if you want to, even right now. So don't worry, you will not miss anything. Okay. Come on, my warriors, what do you guys say? Will it be F? Will it be 2F? Will it be F by 2? Will it be F by 4? Think carefully and try to answer this question. Why will there be a force? First of all, think, because there is a field between the plates, and once there is a field between the plates, what will happen? The field will create a force. Force will be charged into field. Achha, do I know the field formula between the plates? Think, do you know the formula for electric field between the plates of a capacitor? I think I just gave it to you. The field between the plates of a capacitor is the charge on the capacitor divided by A epsilon naught. So that is the value of the force on this charge. Now think carefully. QQ did not change, area did not change, epsilon naught did not change. So distance has no role to play. Hence the answer should remain F. Many people think that because you have increased the distance, that's why the force will reduce. No, nothing will change. The reason is this field is uniform. See, when you have point charges, the forces will change depending on the distance. But this is not a point charge. This is a uniformly charged plate. It is a large plate. So no matter how far you go, the field will remain the same because it is uniform field. The lines are parallel. So the density does not increase or decrease. So it remains constant. So it does not depend on the distance. Yes, and the charge is conserved because the charge cannot go anywhere. So the charge remains the same. So hence the correct answer is F. Moving on to the next question coming up on your screen. The potential difference between two parallel plates which are separated by 1 centimeter is 100 volts. Now the question is, what do you think is the field between the plates of that capacitor? What is the field between the plates of such a capacitor? Come on my warriors, let's see how many of you can do this question. So you have this capacitor and the voltage difference between them is 100 volts and the separation between them is how much? 1 centimeter, that means 0.01 meter. So the question is, what is the value of the electric field? I think this is not even a question on capacitors. If you think correctly, this should be solvable by the knowledge of just electricity and electrostatics. What is field formula? The formula for electric field is del V by del R. If you go from one point to other point, if the voltage changes, then the electric field between them is given by del V by del R. If you know this formula, now you will get it. Hariharan saying C. Let's see whether it is correct or not. So del V is nothing but 100. What is del R? Del R is 0.01. So this will be 100. Okay, 100 into 100, which is nothing but 10 to the power 4 volts per meter. Even if you check the units, you can get this formula very easily. Voltage by meter, voltage by distance. Voltage is given, how much it is? 100. Distance is given, 0.01. Just divide it and you'll get the answer, which is option C. Done, dana, done. Okay, so it's not that difficult. Yes, Suresh Kumar. Very good, Ramu. Very good, Larab. Excelente. Moving on to the next one coming up on your screen now. Perfecto, my warriors. Hi, Mohan Anlab. Welcome aboard. Very good, interesting facts. Correcto, 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 Alisha. Very good, very good, very good, my warriors. Let's see the next question. Again, there are two plates of a capacitor. There is electric field between them. There is a charge which enters, and by the time it reaches here, it deflects. Why does this charge deflect? You might think because there is electric field. And what kind of charge is this? It's an electron. Electron means negatively charged. That means the force on it will be opposite to the field. I hope you know this. If a charge is positive, the field and the force will be in the same direction. If the charge is negative, then if the field is here, the force will be exactly opposite. So on this electron, because the field is here, the force will be like this, and you will see the charge will deflect. Okay, great. Now, my point over here is that if this is that charge E, the force on it, okay, the force on it will be E into E. And if there is force, obviously there will be acceleration this way, and that acceleration, which is force divided by mass, will be E divided by m. Will there be acceleration in the x direction? No. Why? Because the force is in the y direction. There is no force in the x direction. If there is no force in the x direction, if there is no force in x direction, that means there is no acceleration in x direction. That means the velocity in x direction is constant. That means when you reach here, this velocity's component, okay, this Vx will still remain this V0. It will not change. Everybody getting it? So this velocity component will not change at all. It will still remain as V0. The only thing that will be gained is this Vy value. You will just get this Vy. Now the question is, find the deflection, angle of deviation. How much is the angle of deflection or deviation? If you want to find theta, what do you need to do, guys? Trigonometry. Try to think. I know this is a right angle triangle. I know the base is V naught, I just got it, okay. If I know somehow Vy, tan theta will be opposite by adjacent. How do I find this Vy? Oh, I know what to do. I know the acceleration, guys, in the y direction. If I know acceleration, I can find the velocity. Obviously, how? Kinematic equations. Kinematic equations. Let's just do that. So, Vy will be Uy plus Ay into t. Okay. So, what is Uy? Initial velocity in the y-axis. Guys, initially it was moving in the x-axis. So warriors, if it was moving in the x-axis, there is no velocity in the y-axis. That means initial velocity in the y-axis is 0. Okay, so it's 0. Acceleration, I just figured it out. It is EE by m. So EE divided by m is the acceleration, my warriors. Now what about the time? How much time do you think it will spend? Well, that's not difficult to figure it out. See, it was moving with constant velocity, right? In the x direction. If it was moving with constant speed in the x direction and it was always V naught, V naught, V naught, V naught, then the time it takes to go from here to here, that time will be this distance, which is, okay, distance by speed. Okay, distance by speed. Distance is L, speed is just V naught. So the time which it takes to go from here to here, just take the horizontal distance and horizontal speed. So distance is L, speed is V naught. So this time I can just put it as L by V naught. Got it. Great. This is Vy. Now I think I'm ready to find out tan theta. So what is tan theta, my warriors? Tan theta will be opposite by adjacent. Look at the triangle. It is opposite by adjacent. What is Vy? I think I just figured it out. It was L divided by M V naught divided by Vx. What is Vx? Oh, I just figured it out. It was just V naught. So what will this be? This will be L divided by M V naught square. So this is tan of theta. That's all I wanted. If you want theta, it will be tan inverse of this value. Understood? Clear? Is that clear? Oh, yes, Swaroop, if you want to crack JEE, start watching all my classes right from the beginning, bacha. Trust me, it will help you. I have started the classes right from the basic, assuming you know your 9th and 10th concepts. So start from the 11th standard classes and slowly come to the 12th standard classes. Trust me, you will be able to crack it. And I have all my support and all my wishes to you and all the students who would love to crack JEE and NEET and any such competitive examinations. Yep. So let's get moving to the next one. Okay, so brilliant question based on field, forces, kinematics, everything was involved over here. So let's see. Yep, that's the answer. EEL divided by MV naught square. Great. Moving on to the next concept. Different types of capacitors. You should know each and every type. You should know the formula for them. You should know how it looks like also. First type, which you should know, parallel plate capacitor. For a parallel plate capacitor, you have two plates. One of them is positive, one of them is negatively charged. The area of the plate is A. The distance between them is D. And the capacitance is A epsilon naught divided by D. Very, very important. If more area is there, more capacitance. If less distance is there, more capacitance. That's number one type of capacitor. Number two type of capacitor, isolated capacitor. This is a very special type that is only a sphere of radius r, nothing else. You might be wondering, sir, how can that be a capacitor? Think of an isolated capacitor as a capacitor where one of the plate is the sphere and the other plate is infinity. Infinity. So if this capacitor, or basically this sphere, if it is charged, the field lines go till infinity. That's how you can think of this capacitor as. This is very similar to spherical capacitor, let me tell you. In a spherical capacitor, you have, let's say, positive charges, example, inside, the negative charges are outside. So there are two shells, radius R1 and radius R2. You will see field between the two shells. You will see field between the two shells. So you always need two conductors, remember that, for a capacitor. So one conductor is in, one conductor is out. So there is field between them. One of them is positive, one of them is negative. So this is a normal spherical capacitor where the capacitance is 4 pi epsilon naught R1 R2 by R1 minus R2, which is the same as 4 pi epsilon naught 1 by R1 minus 1 by R2. It's the same thing, guys. You can take LCM and do it. When in a spherical capacitor, the outer plate, the outer surface is infinity, it becomes isolated capacitor. That's all you should think about. Okay, so isolated capacitor is nothing but just a single sphere of some radius r and the other plate is at infinity. Is that clear, my warriors? Yeah. Next up, cylindrical capacitor. So two major types are over. One is parallel plate, second is spherical, third is cylindrical. So you think of Kaju Katli. This is Kaju Katli capacitor. Okay, so one cylinder is inside of radius r1, another cylinder is outside of radius r2. There is some gap between them. Inner cylinder, if it is positively charged, then the outer cylinder will be negatively charged. And you can see that there will be field between the plates of the capacitor. Now, what is the formula? It is 2 pi epsilon naught length or height of the cylinder divided by log of R2, bigger radius by smaller radius. Keep this in mind. Okay, keep this in mind. That's all. These are the important formulas. You should know all the types of capacitor. There is no escaping from this, including this one. Many people forget about isolated capacitor. They generally look at 1, 2, 3. They forget the fourth type. Keep this one also in mind. Okay, chalo. Let's start solving some questions on this coming up on your screen now. The plates of a parallel capacitor are not exactly parallel. Wow. The surface charge density will be very interesting question, guys. So you know what this question says? So one of the plates maybe is like this and the other plate maybe is like this. So something like that. So these are the two plates of a capacitor. What do you think will happen in such a capacitor? Is it the surface charge density lower at the closer end? This is the closer, this is the far away end. Will it not be uniform? Each plate, do you think, will have the same potential at every point? Do you think every point on a particular plate will have same potential, or do you think it will have different potential? And option D says only B and C will be correct. A is wrong. Come on, interesting. It's a single correct option. That means only one of them will be correct as a whole. Okay, Hariharan saying D, Nikhil also saying D, Suresh saying D, Lyra Vandan also saying D. Interesting. Let's figure this out if one of you are correct. Okay, let's figure this out. Come on, my warriors. What do you say? Think about it. I will say that try to convert it into an equivalent, circuit, and you will get the answer very easily. Okay, let's have a look at this. Okay, so what we can do is convert this into an equivalent circuit. How do we convert it into an equivalent circuit? Hello Suyash Kashyap, welcome aboard bacha. Try to think of multiple capacitors of different distances. Yeah, think of it like this. One capacitor with very large plate distance, another capacitor with some smaller distance, and so on and so forth, and the last capacitor with a very small distance. And all these capacitors are in parallel. Do you see that? This capacitor, this capacitor, this capacitor are in parallel. So if this is plus V volts and this is 0 volts, then can't you see, guys, that all these plates are at the same potential and all these plates are at the same potential. This, all the right plates are at 0 volts. All the left plates are connected to the same terminal. So they are all at the same voltage. That means if you are on the same conductor, you can think all the points have the same voltage. If you are again on the same conductor, obviously you are at the same voltage. So each plate will have same potential at every point. That means option C is definitely correct. Hello, good evening, Nikhil. Next up, we all know that capacitance depends on the distance. Okay, capacitance depends on the distance. So capacitance is epsilon naught A by D and Q is equal to CV. Now remember one thing, the V is same. Why is the V same? Because they are all in parallel. Voltage difference here, everywhere is same. Hence, as the distance increases, capacitance decreases. So if capacitance decreases, charge decreases. And guys, if charge decreases, what does this tell you? Think about it. The field and the charge density. So charge density, sigma, the charge per unit area will also decrease. So do you think each part will have the same charge density? Do you think each part will have the same charge density? Obviously not, because the distances are different, capacitances are different, and that's why you will see the charges will be different at every plate. So it will not be uniform charge, so it will not be uniform. B option is also correct. Very good. Next, is the lower one having lesser charge density? Is the surface charge density lower at the closer end? Let's think about it. Wherever distance is more, capacitance is less, charge is less, charge density is less. So where distance is more, that means here at the wider end, the charge density is less. So hence this option is wrong. I hope this makes sense. Did you understand it? Well, thank you Adnan for all the love, bachalo. So is it clear, my warriors? Think about it. Okay, so the first option said the surface charge density is less at the closer end. Closer end means distance will be less. That's wrong. Where distance is more, that's where the charge density is less. Hence B and C are correct. That means you will actually mark D option. You will not mark B or C because this is single correct. So you will actually end up marking D option. Perfecto, that's the correct answer, I guess. Very good, excellent. Moving on to the next one. Sir, in the direction of the field, potential decreases? Yes. Always remember, this is a simple rule of electrostatics or even gravity or even magnetism. Wherever the field points, that's the direction in which the potential decreases. Always. In fact, E is minus dV by dr. That minus always stands for, the field points in the direction of the decrease of the potential. That's what it actually stands for. Okay, moving on to the next one. Beautiful question. This looks difficult, but you don't even have to solve it. Let me tell you that. Three spheres A, B, C are shown in the figure. The radii are A, B and C. A and B are connected with a wire. The capacitance of that system is, it's a direct question. Let me tell you that. Hi Roji. Oh, what names? Nice names you guys have. Nice names, my warriors. Okay, figure this out. What do you think will be the correct answer? What is the effective capacitance if this A and B are connected via a wire? If they are connected by a wire, what does it mean? That means their potentials are same, right? If they are connected by a wire, that means this point's potential and this point's potential are same. If potential are same, that means potential difference is zero. If there is no potential difference, the field is zero. So there is no field here, but there is no wire between this and this. If there is no wire between B and C, that means their potentials are not same. If their potentials are not same, that means there will be field between them. If there is field between them, the only two plates which are acting like a capacitor, which are the only two surfaces which are acting like a capacitor. This is one surface and this is the other surface. Now I hope you see the capacitor. This is a spherical type of capacitor, guys. Isn't this? This is a spherical capacitor with B and C as the surfaces. B and C as the surfaces. So what's the capacitance in such a case? C is equal to 4 pi epsilon naught 1 by b minus 1 by c. If you take the LCM, I think you will get this. Yep. So you'll get c minus b and bc will go on the top. Okay, bc will go on the top and c minus b will come here. That means option B will be correct. Is that clear, my warriors? Very good, Nikhil. Very good, Alisha. Okay, Alisha was confused between B and D, but yes, it is B. Yes, Suresh Kumar. Correcto. Yes, Hariharan. Yes, Laira Badnam. Very good. Very good. Correcto, Adnan. Alrighty. So that's what will happen. Okay, very interesting question. You didn't even have to solve this. Yep. Okay. Now going to some questions where you will have capacitors in series and parallel. You know, the funny part is that, my warriors, is that, you know, the method of solving these questions is exactly similar to how you solve resistor related problems. The only catch is that the formulas are exactly opposite. We know whenever resistors are in series, then the effective resistance is R1 plus R2 plus R3, right? But when capacitors are in series, then the formula is the formula of resistors in parallel. So exactly opposite. So when capacitors are in series, 1 by Cs is equal to 1 by C1 plus 1 by C2. That's it. That's the only change. That's what you need to keep in mind. And whenever you have capacitors in series, instead of the current being same, what do you have? The charge is same. Same charge will flow. So because in resistors we always talk about current, but in capacitors what do we talk about? We talk about charges. So the charges will be same. And the voltages, obviously the voltage drop on 1 plus voltage drop on 2 plus voltage drop on 3, the total drop will give you the total voltage. That's what it is. So V is equal to V1 plus V2. So keep this in mind. Very, very interesting concept. So when you have one capacitor here, one capacitor here, another capacitor here, this will be V1, this will be V2, this will be V3. V1 plus V2 plus V3 will be the total voltage drop. And because charge is same, so Q is same, and we know that Q is equal to CV. Therefore, you will see V is inversely proportional to C. You can see that because the product is constant, C into V is constant, so V is inversely proportional to C. That's what this theory says. Interesting, and that is correct. Yep. So exactly. Now in parallel, obviously what will happen? Exactly the opposite formula for what you would expect in resistors. So in resistors, 1 by Rp was 1 by R1 plus 1 by R2. Here, when capacitors are in parallel, it's a simple thing, C1 plus C2, that's it. So think of capacitors in parallel like this. So you have one capacitor here and another capacitor here. Okay, you could have many more capacitors like this, C1, C2. So in this case, understand the effective capacitance will be just C1 plus C2. It's like combining both the plates here and here together, you get one big capacitor. Okay, what about the charges? Well, if this has certain charge, then add these charges Q1 and Q2. So you get one single plate. So Q1 plus Q2 is the total charge of this effective capacitance. Okay, that's what you should remember. The voltage is obviously same, and since Q is equal to CV, therefore Q is directly proportional to C. Because voltage is same, Q is directly proportional to C, because whichever has more capacity, that will have more charge. That's what this theory says. Let's start doing some questions. Yeah. So Nikhil is asking, when dielectric is placed in a charged capacitor after disconnecting, does the charge increase? So when a dielectric placed or whether a dielectric is not placed, if you disconnect the battery, Nikhil, once you disconnect the battery, no matter what you do, the charge won't change unless you remove the dielectric. Okay, unless you remove the dielectric. So once you disconnect the battery, the charge has nowhere to go, so it will not change. But let's say you remove the dielectric, then will the charge change? Well, the answer is still no, because think about it, even when you remove the dielectric, where will the charge come from? There is no way the charge can come from some place, right? So the charge will still remain constant even if you add or remove the dielectric. That's the whole idea. I hope, Nikhil, that makes sense. Hi S. Harni, welcome aboard. So when you disconnect the capacitor from the battery, the charge cannot go anywhere. Okay, moving on to some very good conceptual questions coming up on your screen. And here is the first question. In the given figure, the three capacitors C1, C1, C2, C3 are joined to a battery. The symbols having usual meanings, of course. The correct condition will be only one option is correct. Think which option is correct. Come on, my warriors. Only one of them is correct. This is C1, C2, C3. Think about it. S. Hariharan, G. Hariharan saying C. Hello, Prabha, welcome aboard. So those of you are joining in late, this is the Pathfinder long-term series. And we have already completed the term 1 syllabus on this channel for physics. And if you want detailed classes, they are all there in the playlist Bachalog. And today's class is a backlog revision class, one-shot class. And we started at around 5:30. And this class will be around 2 hours. So if you have missed any part of the class, please, I request you to go behind and catch up at 2x speed or maybe at normal speed. But watch it, whichever part you have missed. And if you think you know it already, then you can continue with the session. Hello Lakshmi Durga, welcome aboard. Suresh Kumar saying C, Nikhil and Alisha also saying C. Well, let's figure this out. First of all, see guys, these two capacitors are in parallel. In parallel, okay, what happens? In parallel, the voltage is same, correct? So therefore, V2 will be equal to V3. That's first thing that you should realize. And this capacitance is in series with this. So this and this, these both are in series. And in series, what is same? The charge is same, correct? The charge is same. Now, on this capacitor as a whole, what is the charge? Q2 plus Q3. So Q2 plus Q3 is the charge because they both are in parallel. This capacitor and this capacitor will have the same charge. So what is the charge on this capacitor? It is Q1. So Q1 will be equal to Q2 plus Q3. Think about it. Q2 plus Q3 and Q1. Both will be equal because both of them are in series. So I think we have an option like that. Q1 is Q2 plus Q3. Okay, this is Q2 plus Q3. Sorry, yeah, this is Q2 plus Q3. And V is V1 plus V2. Yes, that is also correct. I'll tell you why. This voltage plus this voltage will give me total voltage. The total voltage will be V1 plus the voltage across either this or this. Either you can write this or it is also V1 plus V3. Anyways, V2 and V3 are same. So it doesn't really matter because they are in series. So hence option C is correct. Hi, Vanakam Zayed, welcome aboard. Is that clear, my warriors? Yep. So completely based on conceptual understanding. So if you know what is same and what is different in capacitors in series and parallel, that's it. You are going to get this for sure. Moving on to the next question, again based on charge distribution. A, B, A, C, D, E, F. Different charges mentioned on different plates of 3 capacitors C1, C2, C3 connected to a battery of 100 volts. Only one relationship is true. Let's see how many of you are going to get it. Glad to know that, Nikhil. Yep, definitely 0 to hero is also a one-shot series and glad you understood it. Alright, AI Cyberworld saying option D, interesting. B plus A plus F is 0. B plus D plus F is 0. A plus C plus E is 0. B is equal to D is equal to F. Okay, all of you are saying option D. Let's figure this out. Okay, see, one thing is clear. If this is positive, this is negative. This is positive, this is negative. This is positive, this is negative. So QA will be negative of QB. And same thing over here. QC will be negative of QD. And same thing over here. QE will be negative of QF. But this A, C and E, these three, A, C and E, they all will be equal, and obviously, okay, obviously these three, QB, QD and QF, they are also going to be equal. So I think BDF are all equal. Obviously ACE are also equal, but there is nothing like that over here. In fact, if you add QA, QC, QE, you will not get 0. In fact, this is not 0, this is also not 0, this is also not 0. So A, B, C are wrong. Only D option is obviously the correct option. That's it. Excellent, my warriors. Let's move on to the next question coming up on your screen. And here it is. Bacha log. Very good. Beautiful question. There are 1, 2, 3, 4, 5 capacitors arranged, hint, in disguised form. The question is, what is the equivalent capacitance between them? What's the yes, correct, Nikhil. You already realized that this is a disguised form. Very good. So if you do not know what is disguised form, let me tell you what it is. See, it's nothing but where the capacitors are arranged in such a way that it does not look very easy to solve, but actually it is disguised. So if you think carefully and if you mark the potentials, you will immediately understand, array, this is a known form. Oh, this is in series, this is in parallel. Oh, this is the standard form. Oh, I can solve it. So you will realize it if you rearrange it or mark the potentials and redraw it. Trust me on that. So this is actually a very simple circuit. Yes, Devdash. Correcto. Perfecto, my warriors. Excelente. So if you mark the potentials, think this is A, this is A, this is A. This is B, this is B. Okay, then, okay, let's say this one is something else, and I don't know, I can put some other symbol over here, maybe. Yep. Let's start redrawing the circuit and what you will get. So from point A, you have two capacitors. This is a standard form. You have two capacitors like this, and these two capacitors, okay, these two capacitors have this voltage. I'm just putting a circle. One of them ends at this solid dot and another one of them ends at this cross with a circle. Okay, so like this. Now between the cross with the circle and that solid dot, there is a capacitor like this. Now that cross is connected to another cross without the circle via a capacitor. So I have to just reach the cross somehow. So there is one capacitor here like this, and from the solid circle to the cross. So from the solid circle to the cross there is a capacitor, and that's it. That is point B. This is a standard Wheatstone's bridge. And in a Wheatstone's bridge, if these two are in the same ratio as these two, in fact they are, because this is C, this is C, this is C, this is C. The middle one is completely useless. Okay, it's a balanced Wheatstone. So you will just get this capacitor, this capacitor, this capacitor, this capacitor, nothing else. The middle one is completely useless once it is balanced. Once it is balanced, all you need to do is, okay, think these two are in series. So in series, what will happen? 1 by C1 plus 1 by C2, right? So don't write it as 2C, that will be a common mistake. So if you do that also, 1 by C plus 1 by C is equal to 1 by CS. So 2 by C is equal to 1 by CS. So CS is equal to C by 2. This is C by 2. Obviously, this is also C by 2. Now C by 2 and C by 2 are in parallel. So C by 2 is parallel to C by 2. So what will be the effective capacitance? Add them. C by 2 plus C by 2. That is equal to C. Hence the answer is option A. Done, done. Yeah. Even if we write 2C, will you get correct? Yes, Devarsh, because you will be committing the mistake 2 times. So guys, always whenever you commit mistakes, commit it 2 times. If you by mistake write this as 2C, then 2C in parallel, then you divide it by 2. So you should go both ways then. Okay, you should do mistake 2 times. Only then you'll get it correct. Hi Amina, welcome. Yep, that is option A. Correcto. Let's get moving to the next question coming up on your screen. Wow, what a question it is. Amazing question. And let's figure out what is the equivalent capacitance between A and B. Okay, now there is a trick for solving these kind of questions. I'll tell you what the trick is. Whenever you find symmetry, okay, let's say there are 2 points between which you have to find resistance, capacitance, whatever, inductance, doesn't matter. Whenever you have to find the capacitance between 2 such points and there is a symmetry, this is the symmetry, this is such that this is the perpendicular bisector, then all the points on the perpendicular bisector are at the same voltage, let's say V1, 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 because of symmetry, they are at the same distance. Hence, whatever wire is there between them, you can disconnect that. So basically, disconnect the wire connecting on the perpendicular bisector which is symmetric about both the points where you want to find the capacitance. This is the logic you need to use. Is there a perpendicular bisector I can find? Yes, but there is no line which I can disconnect. So I'll just redraw the circuit little bit so that you will get a hang of it. Okay, see guys, so what we do is we just put this capacitor and we just show this capacitor, we show this capacitor, my warriors, and let's see, I'll put this capacitor here and maybe this capacitor here like this and this capacitor here like this. I'll just draw this line like this, and this is one capacitor here like this, and that goes there, and here this is one capacitor, and I go like this is one capacitor, and here also one capacitor like this. Now these 2 capacitors are joined here. I'll just pull it down like that. Okay, so I just pull it down like this and I'll join it like that. See, this circuit and this circuit is the same, my warriors. There is no different. Okay, okay. अच्छा ये तो दिमाग में ही हो जाएगा. Yes, very good Vedant, if it is done. Okay, so now just draw a perpendicular bisector. Just draw a perpendicular bisector. Do you see there is a perpendicular bisector here? Okay, I hope you can see that. This is a perpendicular bisector. So whatever points are there on the perpendicular bisector are at the same voltage. So this and this are at the same voltage. So what you can do, you can disconnect them. That means you can get rid of this and this. Now it becomes a very easy problem because these 2 are in series, these 2 are in series, parallel series, everything is simple. So that's all you need to do. So first of all, these 2 are in series. So in series it will not become 2C, it will become C by 2. So C by 2. These 2 are in series, so C by 2. These 2 are in series, so C by 2. Okay, let us draw the equivalent circuit. But before that, one more thing. You can see this C by 2 and this one, this is C by 2. They both are in parallel. So their combination will be C plus C by 2, which is 3C by 2. Same thing over here. These 2 over here, they both are in parallel. So this will be 3C by 2. So what do we get? Okay, let's see this. So one capacitor, this one over here, the green one is nothing but 3C by 2. So this is 3C by 2, this is C. That one is nothing but just C. Okay, interesting. And then we have just one capacitor in between, which is C by 2. And over here, this is C, this is 3C by 2. Again, same thing. Okay, okay, great. This is what I will eventually get. Now, just try to solve this one over here. These 3 are in series, so what will be the equivalent capacitance? So 1 by Cs will be 1 by C plus 1 by 3C by 2 plus 1 by C. So LCM, take it as 3C. So 3 plus 2 plus 3 divided by 3C. 3 plus 3 6. So it will be 8 divided by 3C. That is 1 by CS. So CS will be 3C by 8. Achha, so this is nothing but 3C by 8. Obviously, even this one is going to be nothing but 3C by 8. Now 3C by 8, 3C by 8 and C by 2, they are all in parallel. So C effective will be 3C by 8 plus C by 2 plus 3C by 8. Interesting. So this will be 3C plus LCM will be 4, right? So you need to multiply by 8. So you need to multiply 2 with 4 to get 8. So 4c plus 3c, the whole thing divided by 8. This is going to be 3 plus 3 6, 6 plus 4 10. So 10c by 8, 10c by 8 is 5c by 4. That's our final answer. Done, done. See if you guys got it. Yes, Nikhil, I have done lots of sessions. In fact, I have done 2 sessions. One session just in resistors, one session just in capacitors. You will find many problems on these, in the Pathfinder, playlist. Just go to Pathfinder playlist. You will see series parallel combination related lectures. You will definitely get lots of questions on these. Definitely. Okay. Hello, Yogesh. Welcome aboard. Yep. Did you enjoy this question? Yep. Very good, Nikhil. Definitely you should watch it. Okay, so completely based on symmetry and series and parallel. So I'm pretty sure this has opened up your mind, and this is also a very standard question where you have infinite capacitors or infinite resistors in series or parallel or some combination, and then you have to find what is the equivalent capacitance or resistance. Okay, I'll tell you the logic for solving these questions. In maths, you are asked to find probably this root of 6 plus like this, infinity. What do you do in such cases? You assume the value is x, correct? And then you think, because this is an infinite series, so how about starting the infinity from here? Because anyways it's a very long chain, so it doesn't matter whether you skip one term or 2 terms, really doesn't matter. So this is also an infinite series, so how about writing this as x? And now you can solve this equation by squaring it. So it will become x square is equal to 6 plus x. It's a quadratic equation, and you will get obviously 2 roots from this, right? This and this problem are exactly similar. There is no difference between them. I'll tell you how. Identify what is repeating. You will see this is the part which is repeating. So if you look at it from here, from A and B, 1 microfarad, 2. 1 microfarad, 2. That's what is happening. Repetition of 1, 2, 1, 2. If you skip the first part, just skip the first part, don't you see it's exactly the same thing as if this is A, this is B. Just hide this and see. This is A, this is B. 1, 2, 1, 2, 1 to infinity. So can I not say that if resistance between A and B is assumed to be, sorry, it's not resistance, my bad. If the capacitance between A and B is assumed to be X, then can I say this problem is very much similar to this problem where this is A, this is B, okay? I have this 1 microfarad, I have this 2 microfarad, and after this, it's exactly the same chain till infinity. So I should get the effective capacitance as X only, because whatever is the capacitance of this entire thing is exactly the capacitance of this entire thing over here, which I have assumed to be X. See if you guys got it. See if you guys got it. Thank you, Sivarathinam. Yep. Definitely answer section. What do you mean by answer section, Ganpati? I'm not sure what you mean by that. Okay, so are you guys understanding why I have taken this as X? Because it's the same thing. So this capacitance of the entire part till infinity is X. Okay, now this is 2, this is X. What are they 2 in? They are in series. Okay, these 2 are in series. So in series, what is the capacitance? Think of the resistors in parallel. How do they behave? R1, R2 upon R1 plus R2, correct? So here it will be 2 C1, C2 upon C1 plus C2. Got it? Great. This and this, do you see they are in parallel? These 2 points, can you see these 2 points? This capacitor and this capacitor are in parallel. So I can very well say 1 microfarad. 1 microfarad is parallel to what? That 2 plus X, series combination. So therefore, the total effective capacitance, which will be X, will be 1 plus that one, which is 2X upon 2 plus X, because that was the combination, 2 and X in series. The effective one was 2X by 2 plus X. Okay, just multiply this now. So it will become x into 2 plus x is equal to 1 into 2 plus x is plus 2x. Okay, I've just multiplied by 2 plus x everywhere. So this will be 2x plus x square is equal to 2 plus x plus 2x. You can clearly see 2x and 2x cancels. So this will become x square minus x minus 2 is 0. Therefore x minus 2, because minus 2 plus 1 will be the factorization. So x plus 1. Yep, minus 2 into 1 is minus 2. Minus 2 plus 1 is minus 1. That is 0. So therefore x is equal to 2 or minus 1. But we know minus 1 is not possible. This is not possible. Hence the correct, because capacitance always has to be positive. So 2 is the correct answer. 2 microfarad. Done, done. Thank you, Rahul Krishna. So I hope guys your concepts are getting clearer and clearer. Okay, and I hope it's a good revision session for all of you. We are covering all the kind of different problems in this one-shot marathon session from your favorite Capto Shreyas Sir. Okay, chalo, let's get moving to the next question, my warriors. And next concept coming up on your screen is where you have parallel or some plates connected to some wires, and the plates are also interconnected, and you have to find the effective capacitance. This kind of questions many people face a lot of difficulty. Let's see whether you students are able to solve this. Okay, done. Yep. Okay. Oh yes, Ganpati, definitely I will do that. Definitely. Okay. Oh, must watch series. Shefuddin Z is asking, sir, which series should we watch? Just like we did must watch movies. So the series you should watch, Shefuddin, will be Pathfinder series and Nurture series. 2 must watch series. Just kidding. Okay.
To do that,
oops, please. My phone. Okay. Stop Siri. Okay. My God. Crazy. Chalo, let's get going to the next one. Thank you, Rahul. Great, you are understanding it. Welcome, Yogesh from Tamil Nadu. Wow, Angel, you are already a VPro student in the Droppers course. Welcome to the session, and you are a Vedan and you are a warrior too. I am very good, Vijay Kumar, Rajmal, Nikam. Welcome aboard. Very good. Oh, Shefuddin, if you have completed your exams, oh, then I will definitely do a session like must watch series as well. So you are in the chill mode now, enjoy mode. Very good. Chalo, let's see how to solve this question. Meanwhile, I had also given some time for you guys to figure out how to solve this. The first thing that you should do is mark the capacitances. Wherever you find plates and a gap between them, that's a capacitor. This is C1, this is C2, this is C3, this is C4, this is C5. So you will have 5 capacitors connected between points A and B. Okay, next up, let's mark the potentials. Okay, now B is over here, so this point is also going to be B. This is going to be A. Okay, then you can see this whole thing is one thing as such. Okay, so this will be, let's say, potential C. Okay, C everywhere. This plate is one conductor, so maybe this entire plate has the same potential D. Okay, you can see that. Fair enough. What I have done, whichever wires plates are connected, I am marking them. So this plate and this plate are at the same potential. This is point B, okay, at the same potential as that point B. This is A, this is also A. This is C, this is also C. Okay. Now let's try to redraw the circuit and see what do we get. Okay, from A, I have 2 capacitors, C4 and C5. Okay, from point A, I have 2 capacitors. Okay, I have 2 capacitors like this, C4 and C5. So this is C4 and this is C5. One of the potentials is A, you can see that. One of the points potential is A. C4 is connected to that cross, which is basically D, and C5 is connected to that dot with the circle, which is C. Interesting. Now the next thing that I can see over here is between that cross and the dot with the circle, there is a capacitor C3 between them. Do you see that? Between oops, sorry, I marked C4 and C4 both times. My bad, guys. This was supposed to be C5. Sorry, my bad. Okay. Now between this cross over here and this circle with a dot, you can see that there is a capacitor C3 between them. Can you see that? So I think I should definitely show one capacitor C3 in between them. Interesting. So that's one thing that I can see over here. Great. Next up, this point D, which is over here, that is connected to C1. Okay, this point D is connected to C1. And that C1 has other terminal point B. Okay, it has another terminal which is point B, which is a circle with a dot, I guess. Okay, whatever. And that is B. And it is just connected to that terminal point B as such. You can see it is just connected to that point B. Are you able to see that? Can you see that, guys? Yeah. Now, oh, if you just mark plus and minus, Nikhil, it will not work. Yep, it will not work. Yeah. Hi, Snehal Dusane, welcome aboard. Now, the last thing, I think there is only one capacitor left because C1 is done, C5 is done, C4 is done, C3 is done. Where is C2? C2 is connected between B and C. Can you see that? C2 is connected between B and this plate is nothing but C. So between B and C, there is one more capacitor. Guys, I know what this is. What is this, my warriors? Isn't this Wheatstone? Isn't this Wheatstone? If this is Wheatstone, don't you see this is also balanced? Because all capacitors are same, my warriors. If all capacitors are same, that's it. Now you know what to do. These two, these two, these two, these two, because the middle one goes off. These two are in series, these two are in series. So when in series, the capacitance becomes half. This is C by 2, this is C by 2. And these two are in parallel. So parallel, you add them. So it will become C. And what is C? C is nothing but epsilon naught A by D. Hence, the correct answer will be option A. Done, done. Yeah. So, what will be the cutoff of all the three subjects, and will CBSE students get quota of about 7%? You're referring to Rahul Krishna, which one? Mains? Advanced? There is no quota like that for CBSE students or anything like that. And for mains, there is no cutoff, Rahul. Only in advanced there is cutoff for individual subject. That's how it is. Okay. So, how to solve these kind of questions? Whenever you have to solve these kind of questions, see what are the different plates, and whatever is this gap between the plates, mark them as capacitances. 1, 2, 3, 4, 5. Next thing, the plates which are connected together, they are at the same potential. Once you get that, start from any point, either from A or from B, and slowly start drawing the circuit. You will see it will be either a Wheatstone or a series parallel circuit. Nothing apart from that. Either series or parallel or Wheatstone. That's it. Once you are able to identify that, rest of the job is very, very simple. Okay, hence the answer is option A. Moving on to the next question. But before that, the concept. Now, what is the energy stored in a capacitor? We know that there are two charges oppositely charged and there is field between them, and always a capacitor will store energy. This energy is always electrical energy. Okay, it is in electrical form, and that electrical energy is given by the symbol U, which is half CV square. You can also write it as half Q square by C. One and the same thing. This is the energy stored in a capacitor. Number one. Number two, the energy density in a field. Wherever there is field, if there is field, there is energy. Okay, there is energy. If there is no field outside, there is no energy. The density of energy, that means the density, okay, density of energy. What is the meaning of density of energy? It is basically energy per unit volume. There is a special formula and you should remember it. It is half epsilon naught E square. Very, very important formula. It is half epsilon naught E square is the energy density formula. Keep this in mind. Energy per unit volume, joules per meter cube. Okay. So electrical energy stored in a capacitor is half Q square by C or half CV square. You can also write it as half QV, one and the same thing. And the energy density is half epsilon naught E square. Keep these two formulas in mind. Hi Suraj, welcome aboard. Yes, Nikhil, very good. Hello Easter. Will there be any energy stored inside the capacitor? Yes, Rahul. Always energy is stored inside the capacitor. Outside the capacitor there is no energy because there is no field and there is no charge outside. Always these charges are in the inner part of the capacitor. There is field only within the capacitor, be it spherical, be it cylindrical, or be it parallel plate. Okay, so there is no energy and there is no field outside a capacitor. Let's solve this question based on voltages and energy. So earlier there are n capacitors which are joined in parallel and charged to the potential V. Okay, so what it means is something like this. So you have n capacitors. Okay, you have n capacitors. Okay, like this. So many such capacitors. Okay, like this, and they are all connected to the potential V. So there is V volts to which these capacitors are connected. There are n of them. Now if these capacitors are separated and they are now joined in series, okay, so you join these capacitors, n of them in series to the same voltage, okay, to the same voltage like this. Now on joining them in series, the energy and the potential difference for the total combination will be how much? That's the question. Are these JEE problems? Yes, Rahul Bacha, they are. Suraj, actually Bacha, aisa hai, you know, we have two channels on Vedantu. One is for English speaking crowd, मतलब जिनको ज़्यादा हिंदी समझ में आता है और English थोड़ा कम. So that's Vedantu JEE channel, and this is the second channel. Both are similar, just that on this channel हम लोग है ना English में पढ़ाते हैं because there are a lot of students who either completely understand only English or the students who want to learn in English even though they know Hindi because they study in English medium, or maybe they want to go abroad eventually and they obviously want to study in that medium in which they are eventually going to converse or they eventually are going to learn, you know, after going to college. So you have both the options, bacha, either this channel or the other channel. Okay, let's see whether you can solve this question coming up on your screen. And here we go. When they are in parallel, the voltage is same. Acha. So each capacitor will have some energy stored, and that is what is mentioned. If the energy possessed by each capacitor is U, interesting. What will it be? U will be equal to half capacitance C. Voltage will be same, V square. Remember, V is same for all of them. That's why I'm writing like this. Now when you join them in series, what will happen? First of all, their voltages won't be V, it will be divided between all of them. So V by N, V by N, V by N. So the voltage across each one of them will be V by N. Okay. Then the energy and the potential difference for the combination are interesting. Let's see. So now when you talk about the total energy, the total energy in this case, the total energy stored in this case, the U total, because there are n capacitors, n into energy stored on any one capacitor. What is that going to be? Energy stored on one capacitor will be half C, voltage will be V by N. V by N square. Do you guys get it? Because voltage will be V by N. So half C V square. V is the voltage on that capacitor. So what will you get? You will get half C V square. This is N, this is N square. So you will just get N. But wait a minute. Half CV square is just U. Can you see that over here? Half CV square is U. So this is U, and what is it? It is U divided by N. That's it. So the total energy is U by N. Definitely it is less than Nu. It is less than Nu, but the total voltage will be, well, I think it will be less than NV also, obviously. Acha, the total voltage, what will be the total voltage? The total voltage will be V, obviously V is less than NV, you can see that. So it is less than Nu and it is also less than NV, hence option D is correct. Yep. It is less than Nu and less than NV, both of them. That's it. I hope this is clear. Yeah. All right. So Lalit, if you are in the home state, that's not like CBSE quota or anything, you have home state quota, bacha. No matter which state you are in, for NITs or any other colleges, you have home state quota for your respective colleges in your state. Be it Tamil Nadu, be it Andhra Pradesh. Okay, option D is correct. Moving on to the next one. Okay. Yes, modern man, you can get 98 percentile plus in JEE Mains even if you start the preparation now. But if you keep postponing it, obviously you will not get 98 percentile. You have to start it. Watch all my playlists. Please watch my backlog classes. Even if you don't understand anything, even if you understand 10%, you should watch it. You should not be like, sir, I'm not understanding anything. If you give up, fine, you will not get it. 100%. If somebody is telling you that, no, you have to understand 100%, only then you will get it, they are wrong. Even if you understand little bit, it's okay. Slowly you will improve, and within no time, after 4, 5 months, 6 months, you'll be like, okay, now I'm getting it. And JEE Mains is long way ahead. It's not going to be in 2 months. It's not going to be in January or February. There is long time for that. Don't worry, bacha. Yes, Deepa, it will. Yes. So moving on to the next question, guys, coming up on the screen. Very good, you win. All right. So this concept cover needs syllabus. Yes, Deepa K. The syllabus is very similar. Yep. So only the type of questions will be different. Archana, please hit the bell icon and also be alert on the Telegram channel, my warriors, because I will post in advance if my lecture is going to be at a different time. Let me tell you, my Pathfinder classes will be either at 7:30 or at 5:30. Recently, I conducted a poll. Many of you said, sir, 5:30 we are comfortable with. See, I'm not changing all the class timings to 5:30. Sometimes, the classes will be at 5:30. Otherwise, it will be usually at 7:30 only. Is that okay, my warriors? All right. Chalo. Rahul, I think first you should prepare for JEE Mains. Once you are confident of mains, then prepare for advance. Else what happens, I have seen this very, very often. Students, they are very, very motivated. That's not wrong, but suddenly they get that jazba and that josh that, okay, I want to crack JEE Advanced. Fine, crack it. But they realize that, okay, these problems are too difficult. What if I'm not able to do this? And they give up. So that's when the studies also stop. So I would suggest, if you are going to lose hope, it's better to start mains first and then prepare for advance. Okay, so it is possible to first crack mains and then prepare in the remaining time for advance also. Many of my kids have done that. All right, chalo, no problem, Archana, it's okay. Just hit the bell icon down there, and you will see there is a bell icon, and you can choose 3 options: notify for everything, do not notify for everything, or notify for some events. Make sure you click on notify for every event so that you get all the notifications. All right, so do the current change after passing through the capacitors? Yes, J, D, J, U, D, U, D. Yes, it will change, bacha, and we are going to see the charging and discharging of a capacitor also in a bit. Okay, so Rahul, if you find some topics are difficult, then trust me, watch my lectures. You will find it easy, and do the easy questions first. Don't do the difficult questions. That is called as selective solving or selective approach. Even for a difficult topic, solve the easy ones so that you get that confidence. Once you have that confidence, then you can crack the harder ones. But initially only if you lose the confidence, that's when the problem starts. Okay, the work done in increasing the voltage across the plates from 5 to 10 is W. What is the work done to increase the voltage from 10 to 15? Okay, so first of all, see, if you have a capacitor and there is a voltage, Okay, whatever work you do, that work will go in changing the voltage difference, that means the energy. So it will basically go in change in the energy stored. That's what it is going in. Well, so in the first case the work was W and the energy change will be half. C I do not know. Voltage is from 5 to 10, so final is 10 square minus half into C into 5 square. So this will be half C into 10 square is 100 minus 25. So this will be nothing but 75 into C by 2 is W. Great. Now in the second situation, okay, in the second situation, from 10 to 15, use the similar concept. The new work will be half C into 15 square, that's the final energy, because whatever work you do will go in increasing or changing the energy, minus half into C into 10 square. Achha. So this will become half into C into 15 square is 225 minus 100. This will be C by 2 into 125. Now I think I can find out the value of C by 2 from here. So C by 2 is nothing but W by 75. So how about substituting that over here, and let's see what do we get. C by 2 is nothing but W by 75 into 125. Both of them are divisible by 25. So 125 divided by 25 is 5. So 5W, 75 divided by 25 is 3. So 5W by 3, where is it? It's option C, my warriors. See if you guys understood it. Thank you, Nikhil. So Rahul is asking, sir, I'm doing it right now. Will I be able to cover the topics? Yes, Rahul, definitely you have time. You will aram se be able to do it. My advice to all the warriors out here is that if you start thinking that I have 10 topics left, many warriors are there who might have 5 topics left, 7 topics left, or even the entire 11th standard topics left. Please start it now. Don't think, sir, not possible, sir, it's not possible. I mean, there are so many students who have been studying for 2 years. I have to spend 1 year of time. No, you don't have to spend 1 year of time. You can do it in the next few months, because if you don't do it now, then how will you do it in the last 1 month or last few weeks? So at least try to cover it up. Maybe out of 10 topics, you might cover 8 topics. 2 topics might remain. Leaving 10 topics is better than leaving 2 topics. Let me tell you that. So start now. I'm pretty sure you will be able to do it. Set up the goal, set up the timetable that by December or by January, I'll be doing these 4 topics. Don't try to cover everything in 10 days. That's not possible. Okay, you will probably take few more days, few more months, but that's okay. JEE Mains is not going to be conducted very soon, my warriors. Don't worry about it. Okay, 5W by 3 was the answer. Next question coming up on your screen right now. And you have 4 attempts. You know, I feel very sad when I think of those students, you know, when these students joined with us, you know, in the month of January, February, and there was hardly 1 or 2 months for the February attempt, you know, and then they were like, sir, I've not completed any syllabus. So they hurried up everything and started studying the entire syllabus within few days. They didn't understand anything. But little did they know that the exam got postponed, and there were 4 attempts, and the last attempt was recent. It was just in August, guys. So think about it. Right from January till August, it's almost 6 months. So had some student planned that, okay, even if I don't do well in the first or the second attempt, I will probably do very well in the 4th attempt or the 3rd attempt. I have 4 or 5 months. I will plan and distribute my chapters. For sure, he would have cracked very well than a student who would have tried to complete the syllabus in the first attempt. So plan it. You have multiple attempts. That's very right. Don't worry, my warriors. Okay, chalo. Pavitra, I recently conducted one term 1 physics and in general strategy session. Please watch it, bacha, on the our channel only. In the past videos it is there. You will be easily able to search it. Please search it, how to cover backlogs, etc. But I'll be definitely conducting one strategy session and timetable for the last 1 month as soon as the CBSE dates are announced. The moment it is announced, I'm going to give you the entire timetable for the month, what you should do when, and how you can prepare for KVPY boards and as well as JEE. Don't worry, guys. All right. No, Sir Veda, maybe my body might be tired, but I'm not tired mentally. Okay, let's do this. Colleges and quota, Rahul, I already conducted one session. You can check it out. Recently I did it. Counseling session. It will be by that name of the best counseling session and all of that. So there is a capacitor which is initially charged up to the potential difference E. It is connected with a battery E as shown. Find the heat loss in the process. Now warriors, what you need to do over here is that look at the problem carefully, because this is not a standard problem. Look at this, positive is connected to negative, negative is connected to positive. So first of all, understand my warriors, this is the initial condition. This is the initial condition. But this will not be the final value. Finally, this will be negative, this will be positive. And what is the charge? Charge is C. Correct? Charge will be C into voltage. So the final situation will be where this plate will be minus CE charge and this plate will be plus CE charge. So this will be the final situation. Now think this way. Look at this plate. There was plus CE charge. Eventually, there was minus CE charge. So how much charge has come out of this plate which has flown into this circuit and gone into the other side? How much charge flows? How much is the charge which flows in the circuit? This was plus C and this same plate has become minus C. Think and carefully answer this. Glad to know you all, warriors. Harikishore, what is the allied batch in Vedantu? Well, it's not exactly allied, it's called topper batch. So we have two divisions, just like in every other institute, bacha. You always have two kinds of batches because some students understand really fast. So we have a separate batch for them, and some students who find it a little bit difficult or who need some extra time, we have our regular batches, just like in every other institute which you will find in any coaching institute out there. Okay, so some of you are saying 1/4 CE square, some of you are saying C, some of you are saying B. No, it's not the correct answer. I'll tell you why. First of all, do you realize this? From plus CE to minus CE, what is the difference? How much has the charge decreased by? It has decreased by 2 CE. Do you understand that? Plus C to minus C, the difference on the number line, if you think of it from the number line perspective, you will get it very easily. This is minus CE. So the decrease is nothing but 2 CE. Do you understand this, my warriors? Pakka? Acha. Now this is the amount of charge which flows. So that is 2 CE. Why do I need that? I'll tell you. See, whenever you read in the question there is heat loss, remember this equation. This is my Shreyas Sir's equation. Remember this. What is this equation? The work done by the battery is change in the potential energy plus the heat loss. And the work done by the battery is always the charge multiplied by the EMF of the battery. Keep this in mind. That's it. Your entire job will be done. Let's try to do this question. Okay. So first of all, what is the work done by the battery? Charge into voltage. What is the charge? 2 CE. The charge which flows. The charge which flows through the battery. See, what is the meaning of EMF? EMF is the work done per unit charge. So the total work done will be the charge into the EMF. That's what will happen. Yeah, that's the trick. Welcome Maria, my new student. Nice to know all my new students out here, and I hope you have hit the subscribe button. And if you are old or if you have already hit the subscribe button, you know warriors what to do next. Hit the like button. It means a lot for me and it shows your love and support for me as well as the channel. Okay, so 2 CE is the charge into EMF is E is equal to. The interesting thing is the magnitude of the charge is same. So the difference of delta U, even if you write it half Q square by C minus half Q square by C, this difference will be 0. I hope you understand this. because the final charge, anyways the charge is squared. So whether it is positive or negative really doesn't matter. The magnitude of the charge is same. Minus 2 square is also 2 square. 2 square is also 2 square. So it really doesn't matter. Delta U is 0. So therefore I have just heat loss over here. This is 0. Therefore the heat loss is nothing but 2C square. Many of you would have made this mistake and written down either C or D. So try and get the concept right. First concept is, remember this Shreyas Sir's equation. Work done by battery is delta U plus heat loss. Work done by battery is charge flowing into the voltage or the EMF of the battery. And how do you find the charge which is flowing? Draw the final and the initial situation and then try to analyze. Acha, this was the charge before, this is the charge now. So how much charge would have flown? Okay, plus C to minus C, that means 2C. That's it. Done, done. Understood? Oh? Yep. Alright, yes, included this in Funda notes. Very good, Nikhil. I have created a session on how to make notes. So you can watch it. Let me tell you one interesting magic. A lot of you don't know this. Magical words. Like Harry Potter has magical words. He has those spells and the magic happens, right? So you know what is the magical words for physics? It's very simple. You should go to YouTube and let's say you have doubt in, let's say for example, I don't know, some chapter, let's say momentum and collisions. Just go to YouTube search bar and just type momentum, okay, and just put Shreyas Sir. That's it. You will get the list of all the videos that are related to momentum and Shreyas Sir. Let's say for example you want the topic of optics. Just put optics Shreyas Sir. You will get the videos. Let's say you want to know how to make notes. Just put notes and Shreyas Sir. You will get all the videos. Let's say you want to find strategy sessions. That's it. Put strategy and you will get all the videos. You don't even have to find and browse through all the playlists. You will automatically get it. You can apply filters if you want to. That's the best part. Okay. Great. Moving on to the next one. Yeah. Dielectrics, and then we are going to go to charging and all of that. Okay. So here it is. What is dielectric? Dielectric is any material which reduces the field and it basically decreases the field because there is induced charges in it. So usually if the electric field is like this, E naught, the moment you put some masala, what is this? Like you add masala in cooking, you add some material. It could be wood, it could be cotton, it could be paper, it could be water. Then what happens? This material creates induced field. It will create induced field inside that material. Hence, the net field which is there, will be the original field minus the induced field. And it is definitely lesser than the original field. And that reduction in field is because of the induced charges in that medium. So that medium is then called as a dielectric medium, which is also a non-conducting medium. Okay, so it's all non-conducting medium. Now this net field, okay, this net field is obviously going to be less than the original field. If the original field is E naught, the number of times it is less, that K is called as the dielectric. This is called as the dielectric constant. Keep this in mind. So if it reduces 5 times, original field is E naught, it reduced 5 times. So new field is 5 times less. So 5 is the dielectric constant. So that number tells me how many times will the field reduce in that medium. That's all. Now, when you have a capacitor, the beauty of that is if you add that masala, if you add the dielectric between the plates, the capacitance increases 5 times. Like, sir, how? The reason for that is simple. The moment you put the dielectric medium, the field will try to reduce 5 times. But you have applied some voltage. You are maintaining that voltage. So it will not allow the field to reduce 5 times. So in order to compensate for that, it will store more charge so that the field is restored back, because the voltage is kept constant. You have connected it to the battery. So that's why it will store more charge to maintain that field, and hence the capacitance increases K times. Is that understood, my warriors? Yep, correcto. So that's how you should remember it. So the capacitance increases K times. Let's solve some questions on this, and here is the standard question. Okay, two parallel plates of area A separated by two different dielectrics are shown. The net capacitance is how much? The moment you see these kind of questions, there are only two varieties in this, remember, my warriors. One is like this, and the second one is like this. You have masala here and you have masala here. Okay, this is K1, this is K2. These two kind of varieties of questions you will get. If you find this kind of problem, you can see the capacitors are one after the other. So this is equal to one capacitor here and one capacitor here. They both are in series. But if you find like this, you can see one plate here, one plate here, one plate here, one plate here. This is one capacitor, this is one capacitor. So this is equal to one capacitor here and one capacitor here. Here you have K1, here you have K2. Here you had K1, here you had K2. That's it. This is in parallel. That's it. If you know these two combinations, you will be able to solve any kind of, dielectric question. Yep. So let's do this. Sir, is this the charge gets accumulated in one part? No, Rahul, it will get accumulated in both parts. Remember, for a capacitor, the charges are always equal and opposite on both the plates. Okay. So only the sign will be different. Okay. Now, because they both are in series, we know what to do. For series, 1 by Cs is 1 by C1 plus 1 by C2. Okay, so 1 by Cs is equal to C1. C1 is this capacitor. Okay, this one, the one on the top, is epsilon naught. Instead of epsilon naught, you will have into K. What is K? K is 1. Be careful. Usually it was epsilon naught A by D, right? Now it will be epsilon naught K A by D. K is the dielectric constant. You have to multiply it K times. What did I tell you? Whenever you add masala, capacitance increases K times. Here it is 1 only, so it increases 1 time. A by D. D is D by 2. So this is the first part. Okay. Second, 1 by epsilon naught. K is 2, so it will increase 2 times into A divided by D by 2. Okay, I think I can shift it on the top. I think D by 2 will go on the top. And epsilon naught A will also be common. So from the first term I have 1 common, and from the second term I have 1 by 2 common. So this will become D by 2 epsilon naught A. 1 plus 1 by 2 is 3 by 2. So this will become 3D by 4 epsilon naught A, but that is 1 by Cs. So Cs will be inverted. So it will become 4 epsilon naught A divided by 3D, my warriors. That's it. 4 epsilon naught A divided by 3D, which is option A. Done, done, done. Did you see that, my warriors? Excellent. Again, Solunga, Magesh, instead of Solunga, we can you can go rewind. Yeah, you can just replay the same part so that I will do the same Solunga again. Okay, same. It will not be different. So the concept, Mangesh, is simple. These two capacitors are in series, one after the other. So K1, K2. This is one part, this is one part. Capacitance for series, what is, capacitor for parallel plate capacitor, what is it? It is nothing but epsilon naught K A by D. So I just substituted this formula over here. Is that okay? Fine, Magesh Kumar. No need of Solunga. Okay, cool. Let's get moving. Okay. Moving on to the next one. Yes, option A is correct. Moving on. Okay. So, understood, oh, clear, oh, my warriors. Next and the last concept. Get ready, my warriors. Charging and discharging. Okay. Very simple topic. Next 15-20 minutes we are done. Done. Okay, glad you understood it, Magesh. So what is the meaning of charging of a capacitor? Simple. You take a capacitor, take a battery, connect it to the battery, charge will slowly build up. It won't build up instantaneously. You cannot charge anything instantaneously. Like for example, when you drink energy juice, you slowly build up that charge. You build up that energy. Same way capacitor also slowly builds up the energy. The current also grows and finally it builds up. Same thing discharging. You drank the energy juice, you work out, you run around, the energy will slowly go away. Same way if you take a capacitor and you connect it to a resistor, the energy gets slowly drained out and the current will take away that electrical energy and it will discharge that energy in that resistor in the form of heat. That's what charging and discharging is, and I have done that derivation in detail in my regular class, but for now just remember the formulas and the graph. Whenever you charge a capacitor, the formula for charge as a function of time, look at this, charge as a function of time, initially no charge, slowly charge builds up, builds up, builds up, builds up, builds up, and it will reach a final value. It will not go on increasing. Obviously, it will reach a final value. This is your steady value. What is this value? This is your steady value. What is that steady charge? The steady charge Q will be C into V, whatever that voltage is. Okay, so that steady charge, you can say that steady charge is nothing but C into V. So what is that value? Q is equal to CV 1 minus e to the power. This is exponential. E raised to minus T by RC is in the power. Remember that. Okay, R is the resistance, C is the capacitance. So the diagram for this will be, there will be a capacitor, there will be a resistor, there will be a battery. That's it. That's what it will be. So there will be charge which will be supplied from the battery to the capacitor. That's what this is. Now the numbers that you should remember is 3763. Yeah, remember these numbers. Wow, welcome new warrior, Q being modified. Welcome aboard. Charging can be through induction or conduction. Well, this is not that charging. Well, this is via conduction. Though that charging that you are talking about, induction and conduction, that was for conductors. You bring a rod and it gets charged. So you bring a rod close around, that gets charged via induction. But you take a rod and touch it, it charges via conduction. This is via, actually speaking, this is via conduction because you are taking the charge via that battery and putting it onto the other conductor. So you are taking it via conducting path. So this is charging via conduction only in a way. Now the numbers, like I told you, which are important is 63 and 37. So remember, there is a number called as time constant. What is this T? This is called as the time constant. And what is the value of this time constant? It is RC. After one time constant, you will see this is 63% charged. 63% charged of the final charge. After two time constants, it will be even more charged. After 5 or 6 time constants, it will be almost a 99% charge. So the time constant you can see is RC over here. Okay, that's very, very important. Another thing, the current can be found out very easily. This current is at the end of the day dq by dt. So if you differentiate this equation, you will get this. That's it. When we take the derivative, if you are very quick with derivatives, you can try it out on your pen and paper right away and you will see you will get this equation. Yep. Yes, this is for 12th bacha. Even if you are in 11th cubing, please watch the nurture series. Wherever you see 11th, class 11th, 2023, nurture, these are the keywords for 11th. Wherever you see Pathfinder, class 12th, 2022, that is for 12th standard bacha. Okay, so this is V by R e to the power minus T by RC. So this is the formula for the current as a function of time. If you look at the current will go down. This is very important, very, very important to look over here. At T is equal to 0, substitute the value of T as 0. So initial current will be V by R, okay, e to the power 0. E to the power 0 is 1. So it will be just V by R. Very, very interesting. But if you put the value of T as a very large number after a very long time, this is basically steady state. In a steady state, very interesting thing will happen. Just see what will happen, guys. The current at infinity will be V by R into e to the power minus infinity. This is nothing but V by R into 1 by e raised to infinity. This is nothing but V by R into 1 by infinity. Because e raised to infinity is a very large number. This is nothing but 0. 1 by a very large number, doesn't matter what V by R is, it's 0. So what does these two values tell you? What do these two situations tell you? Initially, when you connect the capacitor, when you just connect the capacitor, initially the capacitor just behaves like it behaves. How does it behave? It behaves like a closed switch. Because look at the current is V by R. The current is V by R. It's as if the capacitor is not there at all. V by R is the current. Do you see that? So initially when you connect it, it behaves like a wire. Eventually, what is happening? There is no current in the circuit once it is charged. It blocks the current. So that capacitor behaves. It behaves like a what? What does it behave like? It behaves like a open circuit. Keep this in mind. Very, very important theory that you are learning over here. Oh my God, Divakar missing me a lot. Don't worry, I'm always here on YouTube. You can always watch me on YouTube on this channel, of course. It behaves like an open circuit. Correct, Ankit. How do we know when it is 63% charge? Well, so very simple GRK. If you substitute the value of this time as RC, RC cancels. Look at this, RC cancels. This will become e raised to minus 1. E raised to minus 1 is 1 by e. If you put the value of e and you find this value, this number comes out to be 0.63. That number comes out to be 0.63. So it is 0.63 of CV. That means it is 63% of CV. That means it is 63% charge. Does that make sense? Hi Jaya Rajpuria, welcome aboard. Is that now clear? Makes sense? Understood? Clear this charging concept and discharging concept. Are you guys now ready to solve some questions? I'll also give you one formula very similar to that charging one. That one will be for discharging now. Okay. So for discharging, what will happen? It's the same formula except that this one will not be there. Okay. So this is what you do. So you have a capacitor and it slowly discharges. So the electrical energy goes in the heat because this will discharge, the current will flow through the resistor, it will slowly discharge it. So the charge as a function of time will be, this is nothing but your initial charge. This is your initial charge, like you can see over here. This is your initial charge and eventually it will become 0. You can see that. So Q naught e to the power minus t by RC. That's it. And if you differentiate this, obviously if you differentiate this, you will get the current. I generally don't tell my warriors to remember the value of current because derivative is very easy. Just remember this charge as a function of time. Current you can get it very easily. That's it. But here there is a catch. Remember, after one time constant, so when t is equal to time constant, which is RC, this is your time constant, what happens? Look at this, the value of the charge remaining, this point, this is only 37% remains, or you can say 63% is discharged. It's one and the same thing. So that's why 63 or 37 are very important numbers. Just keep this in mind. Clear? Oh, let me know. Think about it. See if this is clear. Okay. No problem, Sanjay Patengia. Please watch it. Today's lecture is amazing. It has cleared and touched upon all the concepts and amazing problems and concepts were covered. If you think you are not that great and confident about capacitors, please watch it from the scratch. It will just take you 2.5 hours. That's it. Not more than that. Okay, we started at 5:30, so we are at 7:30, almost 2 hours. More 10 minutes and we are done. Okay, here are the last few questions coming up on your screen. Now, let's see if you can do this. There are two capacitors connected via resistor. There is a switch. the ratio of the capacitances is 1:2 or 2:1, whatever you want to write it. Initially the switch is open, only C1 has Q. Eventually, when you close the switch, eventually, steady state, what will be the final charges on both the capacitors? Welcome, Sanjay. All right, let's try and solve this. Okay, so this was the initial one. This was the initial state, that is basically t is equal to 0. Eventually, okay, at the steady state, what will happen is this charge will get distributed. Some charge will be here and some charge will be here. Let's say this is Q1, this is Q2. These two charges are at basically the steady state. Now we know the charge always has to be conserved. It cannot get destroyed or created. That means by charge conservation, can I not say the initial charge will be equal to the final charges sum Q1 plus Q2? Very straightforward, makes sense? Cool? Great. Now, the next concept over here is when the steady state is reached, the charges will stop changing. And when that happens, then the voltage across this capacitor and this capacitor will be same. The potential difference will be same. Anyways, this resistor, the voltage difference will be 0 because the current is 0 at steady state. Remember that at steady state there will be no current flowing in the circuit because charges have stabilized. So there is no voltage here. So whatever voltage you get here will be the same voltage here. Everybody getting this point? Okay, so potential difference is same. If potential difference is same, can I not just say V1 will be V2? Done. Now, but what is V1 and V2? Is there a formula? Yes, there is. Q is CV. So V is Q by C. So V1 will be Q1 by C1. V2 will be Q2 by C2. But wait a minute. I think I have been given the value of C2. C2 is nothing but twice C1. C1 goes, 2 goes there. So 2Q1 will be Q2. Fair enough. Now I think the only step left over here is just substituting this value of Q2 over here and see what do we get. Q is equal to Q1 plus Q2. Q2 is 2Q1, which is 3Q1. Therefore, Q1 will be Q divided by 3. This is the first answer. And if I know Q1, I can also get Q2. Q2 will be twice of Q by 3. So therefore, Q2 will be just 2Q by 3. That is our second answer. So Q by 3 and 2Q by 3, that means option B is correct. Yep, very good, Regathan Kandan. So the two concepts used here are whenever you see two capacitors, one is charged or both of them are charged and they are connected to each other, they will generally ask you to find what is their final voltage or what is the final charge or how much energy is stored or how much energy was lost. These kind of questions all have to be solved in the same way. There is no difference. What you need to do? Conserve the charge. Initially there will be some charge, finally there will be some charge. So Q is Q1 plus Q2, first concept. Second concept, eventually voltages will be same. So V1 will be equal to V2. That's where the physics part ends. After that is just substituting everything and just getting the final answers. That's it. Done, done. Moving on to the next one coming up on your screen. Option B was correct. Here it is. Okay, this one is easy. I'm pretty sure you'll be able to do it. After the switch is closed and once the circuit reaches steady state, what is the total current in the battery respectively? Why respectively? There are two situations. The first situation is after you close the switch and you just close the switch. And the second situation is over here, the circuit reaching steady state. So for both the situations, what is the current respectively through the battery? Okay, so this is R, this is R, this is R, this is C, this is E. So when you just close it, what did I tell you? When you just close, a capacitor behaves like a closed circuit, a closed switch. So think about the drawing. Okay, so just think of the capacitor as a wire. You will just see one resistor, that wire, or just the closed switch, and probably over here something like this. Okay, and this one resistor here. I think these options are wrong, by the way. Okay, this battery, and yep, this is how it will look like. Fair enough. This is how the circuit looks like initially when you just connect it, because the capacitor behaves like a switch. This is R, this is R, this is also R, this is E. Now what is the effective resistance, guys? Come on, let's do this. These two are in parallel, so effective will be R by 2. R and R in parallel, R by 2. R by 2 and R, think about it. R and R by 2, what will it be? 3R by 2. Correct? So what will be the current in this circuit? The current will be EMF divided by total resistance, which is 3R by 2, which is 2E by 3R. Okay, so 2E by 3R will be the initial current. Now I see nowhere it is matching, so that's a misprint. Okay, I'll get it corrected, but don't worry. This was the initial part when it is just closed. Everybody clear? Very good, Shashmita. Now for the second part, don't look at the options, ignore that. Second part, when you reach steady state, I have just told a capacitor behaves like an open switch. I have mentioned this. So redraw the circuit. So let's say from the battery, this is the resistor, this is another resistor like this, EMF battery, resistor. This is an open branch. There is nothing which is going to flow through that. Even if there is a resistor, there is no connection here. It's an open switch. So no current will go there. So whatever current has to flow, it will only flow in this part. Now you can very easily see that only these two resistors have to be counted, and their resistance will be just 2R, because they are one after the other in series. Done? So the question arises, what is this current now? Current will be EMF divided by total resistance. So E by 2R is the final answer. So 2E by 3R and E by 2R, these are the answers. Done, done. Yeah, I think it will be either C, most likely it will be C, because everything had 0. This option should have been probably 2E by 3R. Okay, so that was a misprint, so ignore that. So if this was the option, then this C will be correct. Okay, fair enough, understood or clear? Done, done. No, Rahul, the option B is not correct. No, Kandan, option B is not correct. Forget the options. These are the answers. Doesn't matter what the options are. Okay, so ignore that. Okay, last question coming up on your screen. My lovely 12th standard students, let's do this. In the condenser shown, condenser means capacitor, don't get confused. It's just a nickname, just like you have nicknames in school and your relatives and your cousins. So same way, it's a nickname. Condenser shown. The circuit is first charged to 5 volts and left. Okay, so what is the charge on the, in the 12 seconds, what is the charge on the condenser will become? Okay, so let's try to solve this question, because we know this is a discharging circuit. So this is a discharging circuit. So in case of a discharging circuit, what happens? Think, the charge will be a function of time. Okay, the charge will be a function of time, and it will be initial charge into e to the power minus t by RC, right? It is mentioned in the question, the capacitor was initially charged to 5 volts and then left. So if you take a capacitor and charge it to 5 volts, correct? What will be the charge stored on it? Think about it. What will be the charge stored on it? Well, the charge stored on it will be C. C is 2 into 5. So that is going to be nothing but, 2 into 5 volts. That's what it will be. So the charge will be 10. Now, if this much is clear, can we go ahead? Yes, so that will be 5 volts, and that's what it is. Now, in 12 seconds, the charge on the capacitor will be how much? Let's try to do this question. So in 12 seconds, right? So this will be 10 into e to the power, time is 12 seconds divided by RC. R is 6, C is 2. 6 to 12 cancels. So this will become 10 into e raised to minus 1. So this will become 10 by e. So that's the charge, 10 by e. Do I have 10 by e somewhere? Yes, it is. Done, done. That's it. Option A, who was that? Very good, Sashmita. Very good, Ankit. Very good. You guys have been really quick. Excellent, my warriors. That's the correct answer. Yep, 10 by E. Perfect. Oh, we have one more question. I think this is the last question. Okay, so a charged capacitor is allowed to discharge. So there is a charged capacitor. You are allowing it to discharge via an ammeter and some resistor. And you are closing the switch at t is equal to 0. When time is log of 4 microsecond, after a time of log 4 microsecond, what will be the reading of the ammeter? Oh, the reading of the ammeter falls half of the initial value. Then the resistance of the ammeter is how much? Okay, let's do this. Monster saying option C. I don't know whether it's option C or option B or option A or option D. One thing I know, the current as a function of time is original current also e to the power minus t by RC. Standard formula. Initial current e to the power minus t by RC. Everything has same formula for charge, for current, everything. It's mentioned that the current falls to half the value. That means this current is I naught by 2. This is equal to I naught. Okay. This was the initial current. This was initial current. And this whole thing I can write it as 1 by e to the power t by RC. I'll put it below because I don't like negative powers. I naught cancels. So 1 by 2 will be 1 by e to the power t by RC. Acha, flip this. So 2 will be e to the power t by RC. Okay, this is in exponent form. Write it in logarithmic form. So t by RC will be log of 2. Fair enough. Now just substitute everything, whatever you know. Just substitute everything. By the way, assume the resistance of the ammeter to be smaller. Okay, this is 2. So time, what is the time given? Log 4 microseconds. So ln 4 micro is 10 to the power minus 6 divided by R. R is this total resistance. The total resistance is R. So R into capacitance. What is the capacitance? 0.5. So 0.5 micro. So 10 to the power minus 6 is equal to ln 2. Okay, I know what to do. 10 to the power minus 6, 10 to the power minus 6 goes. Log 4 is 2 ln 2. Correct? 4 is nothing but 2 square. So that 2 comes outside. So 2 ln 2 divided by R is ln 2. ln 2 goes. So 2 is okay. So I think, oh, there is this 0.5 also. 2 by 0.5 is nothing but equal to R. So therefore, R will be equal to 4 ohms. But wait a minute, R is the total resistance. That means it was actually R plus this small 2 ohms is 4. So small r is 2 ohms. Done. Option C is correct. Very good, Monster. Oh yes, Ankit. Yeah, we will be celebrating, but it will be a low-key Navratri because of, COVID, and we don't want to risk it by actually going outside. But usually whenever Navratri happens, we always meet up, we go for Garba and Dandiya parties and all of that. We have these nice celebrations even at home. We also celebrate Dashera, and yeah, so it's always fun to celebrate, Navratri. It's fun time and it's good to meet all the people, but probably it is going to be a low-key Navratri this time. What to do? I'm from Pune, but right now in Bangalore. Okay, that's the correct answer, and this is the question that you're going to solve it at home. For sure, please post up the answers in the comment section below, and if you want the solution, it will be fed into our Telegram group later on. So please join our Telegram channel as well. Now, if you want to join my batches, if you want to study under teachers like me, if you want amazing content, and if you want test series and preparation till JEE Advance, including JEE Mains, with mock test, with analysis, with material, everything that you should get. And if you are not happy with your coaching, do consider joining Vedantu. Reason is not because I am teaching in Vedantu. Guys, I have been teaching in many places, before this. I was in offline and I have seen how things work. But the thing with Vedantu course material, the whole idea is that you can sit at home. You don't have to travel. Number one is your safety. Number two, saving of lots and lots of time and money. And number three, you get the best teachers of the entire country at your doorstep. You don't have to go anywhere. You don't have to think, oh, this teacher of this institute is good, this teacher I like it from this institute. When you have all the options of all the teachers, guys, you can learn from any teacher that you want. You can join any batch that you want. So that's the best part. And the material, it has all kinds of questions. So if you are wondering, Vedantu does not have its material, no, we have a material called as Tattva booklet. You'll get easy, medium, hard questions, and it also has notes, it also has formulas, it also has concepts, everything included in the material. And not just that, assignments too. And not just that, you get doubt solving within the class. So you just have one teacher who is teaching. Let's say I am the master teacher, I am teaching. You have another teacher who is solving all your doubts. So 2 teachers per class. In offline, you do not get 2 teachers, you have 1 teacher. If you have a doubt, you are scared whether I should raise my hand or no. What will others think? Here, Baychak, because nobody is going to look at you. You can just ask your doubt, that's it. The class teacher will just, he's there on the separate chat box, he will just answer you. So that's what happens in Vedantu. And guess what? All these subscriptions, oh, don't look at this. This is not 28th June. This is supposed to be Monday. Ignore that. Okay, I'll just probably hide it. That's better. Yeah, don't worry, I'll get it corrected. So the batches will start on Monday. Okay, it starts on Monday, guys. Okay, so it starts on Monday. And the course price is 3,000 rupees roughly per month. You also have the option of EMI. Now, if you calculate it, I mean, just think, in normal coaching, you spend 2 to 4 lakh rupees per year. Accommodation is different and you are not satisfied and there is no guarantee that you will improve. And look at the Vedantu results, more than 900 students have got below 10,000 rank. So your probability of success is much, much higher in Vedantu as compared to any offline or even online institute. So even if you have joined an offline institute, I would say you can still join this. You can choose between the classes. The timetable is flexible. It's all up to you. Make the best use of the Vedantu material and make sure that your rank improves. At the end of the day, what matters? It's not about which coaching you go to. What matters is what is your rank. So try to improve your rank, and you have 3 packages. The Lite has everything what I told you. The Classic has additionally the doubt solving after the class on the mobile app. And in the Plus version, you additionally get the personal mentorship. So all of this, in the Vedantu Pro subscription, and you'll also get my batches. So you can meet me over there. I'm conducting the revision course. And whatever you learn today, you'll get the PDF of this in the Telegram channel link, which is there in the description box. You'll also find the link for joining the Vedantu Pro subscription again in the description box. And one last thing before we end the class, do not forget to like and hit the subscribe button down there to show your love and support. Well, thank you very much for joining here. And thank you guys. I hope you had a great time. Thank you, Monster. Bye-bye, Ankit. Take care. Sir, can I learn term 1 chapters in physics within a month if I'm a fresher? Chandrasekharan, within a month, it will be little hard, but if you are willing to study for 12 hours a day, yes, it is possible. 10 to 12 hours. You put in that hard work, sleep only for 6 hours, yes, you can definitely watch it. And I will tell you one thing, there is a crash course going on right now, Chandrasekharan, for completing entire 1 month syllabus, okay, in Vedantu. So just go to the link, it's there in our video only. So if you are watching our video right now, so probably over here, so there is a crash course link as well. You can watch it. So it will be there here. Okay. So there is a term 1 and term 2. There is a course. There is a class 12th complete pro subscription. So if you just want for CBSE, click on this link and if you just want JEE plus the term 1 syllabus, then you go to the third link. So you'll get everything. There is a crash course running right now, bacha. Okay, please do that. Okay, chalo. Bye bye guys. Thank you very much. This was Shreyas here, your physics master teacher, going live from Bangalore. Hasta la vista.